Welcome to the fourth video in this series, which describes the many features and functions of the Prestec Icon 100 press brake controller. In this video, number 4, we discuss the making of a new part to be bent using the shape making drawing editor and the automatic method and the manual method of designing and testing the bend sequence. Previously, video 3 covered simple bending methods A, B and C using jogging and the quick bend methods, which operate in the simple numeric mode. We now discuss methods D and E, which use the full powers of the Icon 100 to design the part automatically. Bending modes D and E require a drawing to be input to Icon. Select from the home screen the new part. A new part can be sketched with the drawing editor, or sourced from the existing job database, or from a standard template offered by Icon. In this example, we'll use Touch Drawing. Selecting Touch Drawing as the template. The drawing editor can make any line shape desired. Simply touch the screen to create the lengths and roughly the bend angles that you see is required. To add a new bend into any shape, you can use the stretch middle key. In this case we say we might want to end a bend in here. To delete a length, use the remove point key. Reshaping the system. Once you've got the shape roughly as you desire, you can edit or enter the last length. Last length, we'll make it 50 millimeters. From that 50 millimeter dimension, the Icon will determine what it sees as the best fit dimensions based on the drawing that you've done and ratioed those lengths back to the 50 millimeter dimension. In this case now we'll go around and re-edit those dimensions which are not quite correct. This one here should be 35. This one's 35. 135, and we'll make this 42. It's time now to nominate the material thickness and the type of material being used. So we go over to the stock key, change the thickness. In this case we'll make it 1.6 millimeter material, and we'll make it aluminium. Now we can see that all the dimensions are correct. The cut length has been calculated taking into account all of the bend allowances required as 156.95 millimeters. We can now name this part as flashing 1, save as flashing 1. The shape is now designed and named. The next process is to determine the bend sequencing, and that'll be next discussed. Once we've got the part designed and we're on screen S2.2, we can select the method of finding the bend sequence. There are two modes, D and E, in the bending methods list. For the manual mode, to assign the bending sequence, we press on the key Make Sequence. This takes us to the manual editing screen, which you've seen before. Start by clearing the sequence just to ensure that all bends are to be reassigned. To select a bend within the part, press on the square and it will turn dark green. That bend now can be assigned a bend number in the sequence. We'll call it 1. Don't be concerned about the fact that we've tipped upside down. You can fix that if you want to by pressing the flip key. We're now up the right way around. The middle bend we'll set as the third bend in the sequence, and the last bend, as bend 2, we'll set as bend 2. Now we can move the back gauge into position, X to point. That's step 1's okay, bend 1. Bend 2, we need to flip it over back the other way. And we want to gauge off this end, so we will rotate the material around. And we will X to point the back gauge right there. But then we'll drop it to position 1 by clicking this position 0 key. Now we've got the material resting on the land of the X finger, and the X-axis position is adjusted accordingly. The next bend is number 3, which doesn't really work very well, because irrespective of what we do here, we end up with gauging on a strange angle rather than a flat. So I think that despite all of this, we might change the sequence of bend 2 and 3. It appears as though all 3 bends need to be reassigned. So by pressing on the number, they can all become available. The middle bend we'll set as 2. This bend we'll set as 3. And the remaining bend we'll set as 1. Let's test that. We'll rotate that material around so that the longer end is out towards the operator, and we will set the X-axis to point. So bend 1 would be acceptable. Bend 2 we're going to rotate back the other way and set the X-axis to point. And then we're going to flip the material over and execute bend 3 with the X-axis set to point. So bend 1, bend 2, flipped, bend 3, flipped again. Let's try it again. Bend 1, bend 2, bend 3. That will work. Now let's test that out in the automatic simulate mode here. Notice that we are flagging a small crash on the front of the top tool in bend 3. Now for this step, bend 2, we're going to open up to 50. Go back to simulate again. This job would now be ready to run. We go into the job screen and we can start to run the job, and all aspects of how this is done is covered in video 6. Mode E is the simplest and easiest to use. It lets Icon do most of the work, and so to enter into that mode we ask Icon to find the sequence. As the blue line moves up, indicates each time a new solution is found. Icon has now determined the optimal bend sequence for the part. Simply test the bend sequence in the edit job mode. First bend is set OK. Second bend looks acceptable. Third bend looks acceptable. You could proceed to simulate, or in this case, go straight to running the job. All aspects of the job will be discussed in video 6. Thanks for watching.